Hi, I'm Tom Biebighauser with Wetland Restoration and Training. I'd like to show you how it's possible to build a wetland that will last forever. How do I know this is possible? I've studied natural wetlands that are over 10,000 years old and constructed wetlands that were built over 2,000 years ago. Well, I'm anxious to show you the techniques that you can use to build a wetland that won't require maintenance. Let's get started. We call this wetland Booth Pond. It's a natural wetland that's over 10,000 years old. Booth Pond is located on a mountain ridgetop on the Danube National Forest in Kentucky. Booth Pond is a small and shallow basin that's lined with clay that's compacted. The trees you see in Booth Pond are growing on mounds in a natural basin. Booth Pond has a very small watershed. There are no streams or drainages entering Booth Pond. Booth Pond does not have a dam or a water control structure that would require maintenance. The spillway or overflow for Booth Pond is wide and carries water in a sheet-like pattern that does not cause erosion. This is Cliff Palace Pond, a natural wetland in Jackson County, Kentucky on the Danube National Forest. Carbon-14 dating shows that Cliff Palace Pond is over 10,000 years old. Cliff Palace Pond is located on a mountain ridgetop surrounded by sandstone cliffs. Cliff Palace Pond is in a shallow basin. The bottom of the basin is clay that's compacted. The firm basin shows that Cliff Palace Pond dries long enough for bacteria to decompose the leaves and branches that fall into the water. Cliff Palace Pond will dry in a drought. Cliff Palace Pond has a very small watershed. There are no streams that enter Cliff Palace Pond that could fill it with soil. Cliff Palace Pond is a natural basin that is 3 feet deep in the middle. Cliff Palace Pond does not have a dam or a water control structure. This wetland was built by humans over 2,000 years ago. The wetland and many others like it were built by shaping and compacting clay to form basins on a ridge that's high above the Little Miami River in Ohio. There are 114 wetlands that were dug by hand over 2,000 years ago at the Fort Ancient Earthworks and Nature Preserve near Oregonia, Ohio. The wetlands at Fort Ancient were dug by hand using mussel shells and sticks. The soil that was removed was carried by hand in baskets to build 3.5-mile-long earthworks that encircles the outer edge of the ridge above the Little Miami River. The constructed earthworks is not a dam. Most of the constructed wetlands at Fort Ancient contain water in the winter and spring and dry in the summer and fall. We call these wetlands that dry from time to time vernal ponds or ephemeral wetlands. The wetlands at Fort Ancient are from 1 to 3 feet deep. They're deepest in the center with gradual slopes around the edges. Trees and shrubs are not growing in the wetlands. This shows that they hold water long enough so that trees and shrubs can't grow. The wetland basins at Fort Ancient contain clay that was purposely compacted. Some of the vernal ponds are lined with gravel. The gravel was carried by hand in baskets uphill from the Little Miami River. The vernal ponds are being used for breeding by fingernail clams, frogs, toads, salamanders, and dragonflies. One reason the constructed vernal ponds have survived this long is that they dry annually. This creates conditions where the leaves and branches that fall in the water will decompose and not fill the basins with soil. Each wetland is surrounded by a very small watershed some call a catchment. There are no ephemeral, intermittent, or perennial streams or ditches like this one that flow into the wetlands that would have filled them with soil. The wetlands are based on compacted clay, so water is slow to soak into the ground. Tree roots growing under the vernal ponds cannot remove water from the ponds because of the compacted clay layer. The overflow or spillway for the wetlands at Fort Ancient earthworks are wide. This allows water to leave the wetlands in a sheet-like pattern and not cause erosion. The wetlands are located on high ground, not on the floodplain of a river or a stream where they could fill with soil during a flood. The wetlands have not been drained or filled with soil like what is done to create farmland. The wetlands were not built with dams like this one that can fail. The wetlands were not built with water control structures that will leak and fail to hold water. Let's look at how you can build a wetland like this one that was restored on a mountain ridge in Kentucky 14 years ago. Most natural wetlands are found in shallow basins with natural high ground or a rim bordering the downhill edge. The natural rim is generally wider than 20 meters and has gradual slopes no steeper than 5%. The natural rim acts like a dam but does not look like a dam because of the low elevation and gradual slopes. Wetlands are drained by digging a ditch through the rim of a natural wetland. The soil contained in the rim is then used to fill the wetland basin. This LiDAR image shows the basins of drained wetlands and the ditches that were dug to drain the wetlands. Restoring a wetland involves reshaping a basin that will hold water and filling ditches that were cut through the rim of the natural wetland. This large basin is for a wetland measuring 1 hectare in size. The wetland basins you build can be large or small. You can build a wetland basin to be shallow like this one, or deep like this one. The wetland basin can be shaped to be smooth or varied with pits and mounds so shrubs and trees may grow in the wetland. Start the design process by identifying an area where there is no stream, no ditch, or drainage that would enter the wetland. This is a good place to build a wetland that will last forever because the area does not flood and there are no streams or ditches entering or leaving the area. Walk around the area to identify and map ditches. Examine ditch banks carefully to see if you can find the outlets of buried drainage structures. Look for pieces of pipe that indicate drainage structures were buried on the site. Look carefully for vertical holes that often indicate the presence of buried drainage structures. Set up a long-range laser level with a red beam on a tripod next to the area where you want to build the wetland. Use a laser receiver and a dual-sided grade rod to measure the change in elevation from the upper to the lower edge of the wetland you would like to build. Record the elevations you take with a dual-sided grade rod on a GPS and on a wetland design form. Use plastic flagging to mark the perimeter of the area where you would like to build the wetland. The area you mark should have no more than a 2-foot or a 61 centimeter change in elevation from upper to lower edge. Lay out a wetland with a natural shape like this one we built at Ball State University in Indiana. Don't mark a rectangle or square with straight lines that look artificial like this pond that someone else built. Use an open-face clay auger to dig a deep test hole near the center of the wetland you would like to build. Wait and see if groundwater enters the hole. You may be able to use the groundwater technique to build the wetland if water seeps into the hole and rises near the surface. Use the ribbon test to measure clay content in the soil. You may be able to build the wetland using the surface water technique if you can form a long and thin ribbon that does not break that is at least 2 inches or 5 centimeters long. This open-face clay auger contains soil that is very high in clay. One would need to use an aquatic-safe liner to build a wetland on this site. This is because the short sections of ribbon show that the soil is low in clay. Also, groundwater did not enter the test hole. An aquatic-safe liner is needed to build a wetland on this site because groundwater did not enter the test hole and the soil texture is low in clay. I strongly recommend using an excavator to dig deep test holes when designing a wetland project. One could better see and measure the depth and the thickness of soil layers that are exposed in the deep test holes dug with an excavator. This deep test hole shows that groundwater is near the surface and a wetland may be built using the groundwater technique. The reason groundwater is not at the surface is that ditches and buried drainage structures were installed to drain the historic wetland so it could be farmed. This table can help you choose the best technique for building a wetland on a site. Each technique is based on soil texture by layer and the elevation of groundwater that's found in the test holes you dig. This key can help you choose the best technique to use for building a wetland on a site. Here's a wetland that was built using the surface water technique with a groundwater dam. The surface water technique with the groundwater dam is used where there is a thick layer of clay over a thinner layer of gravel that overlays impermeable bedrock or a very thick layer of clay. When building a wetland using the surface water technique with the groundwater dam, it is of critical importance that buried drainage structures are removed and subsurface permeable layers of soil are interrupted by digging a core trench around the lower 2/3 perimeter of the wetland you're building, and then filling this core trench with clay in thin layers that are compacted to form a groundwater dam. I developed the surface water technique with a groundwater dam because it is the most effective and the lowest cost way to build a wetland of any size. Groundwater dams are effective because they block buried drainage structures that are made from wood, rock, clay tile, or plastic. They reduce water losses from roots, root channels, and topsoil. They block water leaving the wetland underground in permeable layers of organics, gravel, sand, silt loam, and loose clay, and they allow burrowing crayfish to live in your wetland without draining the wetland. A groundwater dam is built along the lower 2/3 perimeter of the wetland you've designed. The top of the groundwater dam should be equal to or higher than the elevation of water or saturated soil in the wetland that you're building. To restore a wetland, it is necessary to fill the ditches and to restore the natural rim along the lower side of the wetland that was drained. The groundwater dam will block the flow of water in buried drainage structures and in the ditches that have been filled. A groundwater dam should be used wherever you are blocking a ditch to build a wetland. The groundwater dam will block the water you see flowing in the ditch and the water you can't see that's flowing underground in the ditch. Here's where a groundwater dam should be built when you are building a wetland that is near a ditch that cannot be blocked by the project. The groundwater dam will prevent the ditch and the water flowing in underground drainage structures from drying the wetland that you're building. Here's how we use an excavator to build a groundwater dam to block a ditch as part of a wetland restoration project. The excavator begins by digging a trench across and perpendicular to the ditch. The ditch is shown by the red arrow. The soil that is organic or low in clay is placed along the downhill or downstream side of the trench being dug. This soil will not be placed back in the trench. The soil that is high in clay is placed along the uphill side of the trench. This clay will be placed back in the trench to form the groundwater dam. The excavator operator digs down into a very thick layer of clay that is gray in color. The clay soil that was saved is mixed and placed back into the section of trench that was dug. The operator compacts the clay soil in layers using the bucket on the excavator. To gain maximum compaction, the operator tips the excavator forward so the entire weight of the machine is on the bucket. The core trench is dug and filled in sections to build the groundwater dam. The additional soil needed to fill the core trench is obtained from within the wetland basin being restored. The groundwater dam will help block the flow of water both in the surface and underground in the ditch. We built this wetland using the surface water technique with a groundwater dam over 36 years ago. We built this forested wetland 25 years ago using the surface water technique and a groundwater dam. Here's a wetland we built 30 years ago using the surface water technique with a groundwater dam. We built this wetland at Sweetbriar College in Virginia using the compacted clay liner technique. The compacted clay liner technique is used where it's not possible to build a groundwater dam and there's a layer of clay near the surface that is at least 4 feet thick. The compacted clay liner technique is difficult and costly to use. This is because it is necessary to spread and compact in layers clay so that it is at least 24 inches thick in the basin to form a wetland. Here's a retired sister at St. Anne's Convent in Melbourne, Kentucky, helping us mark the perimeter of a wetland to restore in an old field. The soil test holes we dug showed that there was a 3 to 4 foot layer of clay near the surface with dry sand beneath. We began construction of the wetlands by using an excavator to remove the vegetation and the topsoil. The vegetation and topsoil were placed in a pile for later spreading in and around the completed wetland. The next step involved removing and piling all the clay within the planned wetland area. We were careful to pile the clay on bare ground so it would not become mixed with vegetation and topsoil. We now used the excavator to remove sand that was beneath the clay. We removed a layer of sand that was from 24 to 48 inches thick. We dug out enough sand so that 24 inches of clay could be placed over the sand in the basin without filling the basin. We set up the laser level on a mound so the beam would be above the tall vegetation in the field. We first used the laser to measure how much sand to remove and then to monitor the thickness of compacted clay we used to line each basin. Here the excavator is being used to spread a 6-inch thick layer of clay over the sand in the basin for the wetland. The excavator then travels over the layer of clay to compact it. The next step involves traveling over the layer of clay with a tractor that has rubber tires. To obtain greater compaction, the tractor operator carries a full bucket of soil as it drives over the clay. The tractor operator travels around the wetland basin in different directions to compact the clay. The excavator spreads the second layer of clay over the first layer of compacted clay. The tractor travels over each layer of clay multiple times until it's compacted. We frequently measure the degree of compaction with a penetrometer and the thickness of compacted clay using a laser level. We keep adding and compacting layers of clay until there is at least 24 inches of compacted clay over the entire wetland basin. The topsoil that was saved is now spread over and around the compacted clay in the wetland basin. The excavator is used to plant clumps of vegetation that were saved when the area was cleared. Wheat and native plants are seeded in and around the finished wetlands. Here's how one of the wetlands we built at St. Anne's Convent using the compacted clay liner technique appeared 3 years after construction. Here's one of the wetlands we restored using the compacted clay liner technique near the community of Sparwood in British Columbia. This small vernal pond was inadvertently created using the compacted clay liner technique when iron ore was mined in Bath County, Kentucky almost 100 years ago. We built this wetland using the groundwater technique near Meadow Creek in British Columbia, Canada. If groundwater fills the test hole you dig, then you may be able to build a wetland on the site using the groundwater technique. Here's how a vernal pond wetland we built looks in the spring on a site where groundwater is near the surface in the spring. And here's how the same vernal pond looks when the groundwater drops to more than 6 feet below the surface in the fall. Here an excavator is being used to build a wetland using the groundwater technique. Groundwater is rapidly filling the depressions being made by the machine. The excavator operator keeps the machine from sinking by placing logs under the tracks. Logs are placed in the wetland to provide perches for birds and turtles with basking sites. Here the excavator is digging a core trench for building a groundwater dam. The core trench is being dug perpendicular to the flow of water in the ditch. The ditch is shown by the red dashed arrow. Here are some of the pipes unearthed when digging the core trench for the groundwater dam. The disadvantage in using the groundwater technique is that there's a lot of soil that needs to be spread. Think of how much space it would take if you flipped a pie out of a pie pan. The same is true when digging a wetland using the groundwater technique. Here's one of the wetlands we built using the groundwater technique the day it was finished. The site looks unattractive with all the exposed mud. This photo shows another wetland we built using the groundwater technique. The new wetland doesn't look good because the water is muddy. The photo was taken the same day the wetland was built. The new wetland looks great 1 year after construction. The logs are being used by the western painted turtle for basking. The soil we removed and spread has become wet meadow wetland. While building the wetlands, I could hear water running near the wooden bridge that people were standing on. The sound was made by water flowing over the head cut under the bridge. We had to control the head cut before it could advance and destroy the wetlands we were building. The excavator began by digging a deep trench across the floodplain of the ditch immediately upstream and adjacent to the head cut. We dug the ditch deeper than the bottom of the ditch downstream of the head cut. We used a tape to measure the length of the trench that spanned the floodplain of the ditch so we could find and cut trees that would fill the trench. We used the excavator to place the largest diameter trees we could find in the trench. We worked to fit the trees tightly together in the trench. The excavator operator used the bucket on the machine to push the logs into the ground and to pack them tightly together. Soil was pushed into the gaps between the logs and to cover the logs, forming a wide floodplain with low banks and a narrow channel in the middle for water to flow over the logs into the deeper channel downstream of where the head cut was located. The floodplain was shaped so that water would flow over the logs in a sheet-like pattern and not cause erosion. Clumps of sedges were embedded into the soil over the logs to control erosion. I've been using aquatic-safe liners to build wetlands like this one, and this is where clay soils are not present and groundwater is not near the surface. We've been building wetlands for rare species of amphibians and reptiles across North America using aquatic-safe liners. This drawing shows a profile view of how a wetland may be built using a one-piece factory-seamed aquatic-safe liner that is protected on both sides by thick layers of geotextile and covered with at least 6 inches of soil. The most efficient way to build a wetland using an aquatic-safe liner is to use an excavator. Here the excavator removes trees and shrubs from a location where a wetland is being built. You can see a piece of rebar that we used as a stake to mark the center of the planned wetland. The excavator digs a deep hole in the center of the area where the wetland is being built. The elevation in the bottom of the hole is equal to the final depth of the planned wetland, plus the thickness of soil to be placed over the liner and geotextile. The stake serves as a guide when digging the basin for the wetland. The wetland basin is dug deepest in the center with slopes no steeper than 20%. The gradual inside slope prevents soil that is placed over the liner from slipping downhill if deer or elk wade into the water. Digging the wetland basin is much like removing pieces of pie from a pie pan. It is of critical importance to be on site working with the heavy equipment operator to build a wetland using a liner. Here the end of the tape has been placed over the rebar stake. The tape is stretched out to a distance equal to the radius of the liner being used. A laser level is used to check the elevation of the ground at a distance equal to the radius of the liner being used. All the elevations around the perimeter of the basin must be the same. Any low spots would reduce the depth of water in the finished wetland. Elevations are checked before the excavator moves to dig another section of the basin. Once the basin is dug, all rocks are removed by hand before the liner and geotextile are placed. Removing the rocks from the basin takes time, but helps to ensure that the wetland will hold water as planned. A pickup truck is used to transport the liners and geotextile from where they are stored to the work site. A thick layer of fabric called geotextile is placed in the basin to protect the underside of the liner being installed. A fish-grade, aquatic-safe liner is placed over the geotextile. Another layer of geotextile is placed over the liner to protect the surface of the liner. 12-inch long landscape spikes are used to anchor the top edge of the liner in geotextile. These are placed 1.5 feet apart. The 12-inch long spikes are used to anchor all 3 layers, preventing the materials from slipping when being covered with soil. The corners of the material are cut and removed before covering with soil. Wire flags are placed along the perimeter of the geotextile and the liner to show the excavator operator where the liner is located while covering with soil. Here is the aquatic-safe liner that's sandwiched between layers of geotextile and it's ready to be covered with soil. The basin is shaped like a large satellite dish. The excavator is used to place from 6 to 8 inches of soil over the liner and geotextile. Absolutely no heavy equipment is allowed to travel over the liner. The liner will tear and the basin will fail to hold water if any part of heavy equipment drives over the liner and geotextile. At least 6 inches of soil is placed over the liner, including the top edge of the liner. The pink flags show the excavator operator where the edge of the liner is located. Here's how the wetland appears after the liner has been covered with soil and large woody debris has been placed. This wetland was built 5 years ago in California using an aquatic-safe liner. The wetland is being used by the federally threatened California red-legged frog. This wetland was built 4 years ago on BLM land in California using an aquatic-safe liner. It's also being used by the California red-legged frog. Here's a wetland we built 10 years ago with an aquatic-safe liner at the Falmouth High School on Cape Cod, Massachusetts. Wetlands may be built any size using Aquatic-safe liner. Here we're building a wetland that's 1.5 acres in size and 10 feet deep using Aquatic-safe liner. The liner and geotextile are placed in the basin in strips that are 24 feet wide. A professional crew seams each strip of geotextile and liner material. A large excavator and wheel loader are used to cover each strip of liner and geotextile before the next sheet is seamed. No heavy equipment or wheeled vehicles are allowed to travel over any part of the liner and geotextile. Here's how the large wetland appears 4 years after construction. This is the stream we built that supplies water from a well into the large wetland. The stream was also built using Aquatic-safe liner. Avoid building a dam if you're serious about building a wetland that will last forever. All dams require frequent and expensive maintenance or they will fail to hold water as planned. Even low and wide dams like this one require frequent maintenance. I've built over 1,400 dams in the past 47 years, and I have yet to figure out how to build a dam that does not require maintenance. Building a dam is a traditional practice, one that must end if you want a wetland to last for thousands of years. Muskrats are the main cause of dam failure in North America. Muskrats will burrow into the dam and cause the dam to fail. The entrance to a muskrat burrow is below the surface of the water. Muskrats build a living chamber in the portion of the dam that is above the water level in the wetland. Over time, muskrats will burrow through the dam. This can cause the dam to wash out in only a few hours. This muskrat burrow goes through the dam. We had to drain this wetland with a pump so the muskrat burrows in the constructed dam could be repaired. One must use heavy equipment to dig out and expose the muskrat burrow and then fill the trench with soil that is high in clay and compacted. The wetland should be drained prior to repairing muskrat burrows. This photo shows a muskrat burrow that goes through the dam. Muskrats will quickly destroy a dam that has water on both sides. Here's where a coyote dug out the muskrats that were living in a dam. The large holes drain the wetland. Here's where beaver have blocked the spillway constructed to prevent water from flowing over a dam. This can cause the dam to wash out. Beaver blocking spillways with their dams have caused many dams to erode and wash away. Beaver have dug a channel through this dam. The beaver channel is draining the wetland like a ditch. Here's another canal beaver dug through the top of the dam of a constructed wetland. You're looking inside of a flashboard riser water control structure that beaver have blocked. This can cause water to flow over and wash out the dam. The red arrow points to the top of a flashboard riser water control structure that has been covered by beaver. The water control structure is still leaking because water is flowing through the gaps that are between the boards in the water control structure that's below the surface, and this is draining a very large wetland. The island you see is where beaver have buried a water control structure in a constructed wetland. It would be very difficult and costly to repair the structure. Livestock have damaged this dam and the spillway for the dam. This dam is also being damaged by livestock. This wetland was built by constructing a dam across an ephemeral stream. The wetland is failing because the spillway is too narrow and carries water down a steep slope. Two major head cuts developed in the spillway, and these are carving a deep canyon that will cause the dam to fail. The dam will soon wash away and the wetland will go dry. You're looking at Drew Lake, a natural wetland on the Umpqua National Forest in Oregon. Drew Lake was about to be destroyed by head cuts that were located in a small stream flowing out of Drew Lake. The location of the head cut and the stream are shown by the red arrow. The red arrow points to the head cut. The head cut is advancing into the wetland and would soon destroy the wetland. We controlled the head cut by installing a buried vertical grade control structure that was made from rock across the 100-year floodplain of the stream. Avoid using pipes in wetland construction. This leaking drain pipe was discovered when rebuilding a failed wetland. No one was aware of the presence of the pipe. This leaking pipe is draining an impoundment that was constructed 50 years ago. Avoid using water control structures in wetland construction. All water control structures will eventually fail, draining the wetlands that are built with them. Ice has damaged this water control structure. The dam is also riddled with muskrat burrows and beaver canals. Avoid using valves and boxes when building wetlands. These will eventually fail. This rotted walkway leads to a water control structure valve that is rusted and needs to be replaced. The open valve can no longer be closed because the valve is rusted. The open water control structure is draining a huge wetland near Golden in British Columbia. I have installed over 1,000 plastic and fiberglass water control structures in wetlands. All will eventually leak and require maintenance. The plates in modern water control structures contain rubber gaskets. These gaskets will compress and tear, causing leaks that drain wetlands. The gaskets must be replaced every few years. This person is trying to close a leaking valve in a water control structure that's draining a constructed wetland. An outdated way of building wetlands is to surround a field with a poorly made dam and then install a pump to fill the impoundment with water. Wetland managers have found that this technique does not work. Pumps require frequent and expensive maintenance, and the cost of purchasing electricity to operate pumps is very high. Wetland managers will tell you about the serious and expensive problems that are associated with using pumps and wells to fill wetlands. A tremendous amount of money and time are wasted pumping water into constructed impoundments that leak worse than a bucket with holes in it. When working with engineers, require that all wetland projects be designed and built without using dams, berms, levees, dikes, diversions, ditches, wells, pumps, or water control structures. I have found that people will rarely, if ever, maintain a dam or a spillway or water control structure after I build the wetland. This is why it's critical you don't build weaknesses into wetlands that will require maintenance. It is possible to build a wetland that looks and functions like a natural wetland. It is possible for us humans to build wetlands that will last for thousands of years. If you look, you can find examples of human-made wetlands that are many years old. Insist on using techniques to build wetlands that will not require maintenance. I recommend taking these steps if you want to build a wetland that will last forever. Avoid building a dam, berm, or dike that's higher than the natural rim of the wetland that was drained. Avoid using a water control structure, drain pipe, or overflow pipe. Just say no to using pipes. Choose a site with a small watershed. Act to control all head cuts and erosion in the drainages entering and leaving the wetland you want to build. Use one of the techniques I've described that have proven successful for holding water. Build a wide spillway that carries water over a gradual slope that will not erode. Please watch the videos I've produced to learn more about building wetlands that will last forever. I'm not sure why anyone would build a wetland with a dam and a water control structure when they know it's going to require maintenance in a few years. This would be like buying a home that doesn't have a foundation. There's bound to be problems before you know it. Well, if you like this video, please let us know. And please hit the subscribe button so you won't miss any future episodes. And I wish you every success building wetlands in your community.